Finally, let's do one more problem. Okay, so here the proportion in 2013 of people who use cell phones while driving was 19, or 0.19, or 19%. A random sample of 200 is taken currently, where 49 out of the 200 were observed driving with a cell phone. Here, so then it continues to say, can we say that the proportion has changed, or is it different? So different or change, that means not equal to. Okay, so here we're testing, is the proportion the same as what it was, 0.19, or is it different, not equal to 0.19? Again, this is a two-tailed test. Here I'm talking about proportion, so this is going to be a Z test. Here the sample proportion was 49 out of 200 and the hypothesized proportion was 0.19. Okay, so I can find the test statistic. Okay, so here's the test statistic. In this case, I know that it's a two-tailed test by looking at the sign. Therefore, I've got both of these test statistics. I've got two areas that will contribute to make the p-value. When I go to my tables, this is a Z test, so I'll go to the Z table. I can look up here, negative 1.9 and 0.08, and find that the area is 0.0239. Okay, that area here is 0.0239. Then the p-value is 2 times that. The p-value is 0.0478. Okay, this I'm going to compare to alpha. In this case, alpha wasn't 5. Usually alpha is 5%, but here it wasn't. Alpha is 1%, just to see what happens when we change things like that. Okay, so here my p-value, which usually I would say is smaller than 5%, is clearly bigger than 1%. So here I've got a p-value larger than alpha. So when I've got large p-values, that means I failed to reject null hypothesis. So here I'd say, based on this data, it appears that the proportion of Calgary drivers who use cell phones while driving is not significantly different than 0.19. If, however, alpha was 5%, then p-value would be smaller, and I would reject the null hypothesis, and I would say that it does appear that there is a significant difference. Okay, so let's see this in the computer first. Basic stats, one proportion. Summarize data. Here I am saying that 49 out of 200 were looking at their cell phone. The hypothesized value is 0.19. The options here I want to do a two-tailed test, and I want to have 99% confidence using the normal approximation, of course. Here's my test statistic and my p-value. Again, the point that I really want to drive home here is, when you tell Minitab the sign in the alternative, you do not have to do anything to the p-value. The p-value is what it states. You do not have to multiply anything by 2. You don't have to divide anything by 2. You don't have to do anything to it. You only have to do the multiplication by 2 when you're doing this by hand. Okay, so there is the p-value. 0.04, just like we got. Very similar, a little bit of rounding error, of course. Okay, so the other thing that we can see from our Minitab output is that we are 99% certain that the proportion is in between 17-ish and 32-ish. Okay, so we're 99% sure the proportions of Calgarians using the driving is between this and that. Okay, 19 does appear to fall inside this interval. So what we're saying is it is possible that the proportion is in fact 0.19, okay, which is why we are failing to reject the null hypothesis. Two additional questions that I want to ask you here. What type of error could have been made? Okay, so here we are failing to reject the null hypothesis because the p-value is larger than alpha. What does that mean? Well, we failed to reject the null hypothesis. It is possible the null hypothesis may have been false. That would be a type 2 error. So here, the possible error that we've made is a type 2 error. An additional question to get you thinking. At what level of significance would we have made a different decision? As you can see, when alpha was 0.01, we failed to reject the null hypothesis. If alpha was 5%, 0.05, then we would have rejected the null hypothesis. So when would we have switched? Okay, and when you look at the p-value, you realize that if alpha was greater than whatever the p-value is, that's when we would have switched our decision from failing to reject to rejecting. Okay, which brings up a very good point. When you are doing research, you need to select your tolerance level or your level of significance before you actually run the test. Okay, because when you run the test and then you decide the level of significance, you can just make whatever the data, you can make the answer be whatever the data, whatever you want it to be, right? Okay, so here I could just change alpha to make whatever the person who's paying me to do this study, I can make the study show anything I want to show. So you need to make sure that you select alpha before running the test.